Uses of alkyl halides used as solvent. Okay. Then second use, it is also used as reagents for the synthesis of other compounds. It is used as anesthetic. Do you know what is anesthetic? Anesthetic. What is general anesthetic? What is local anesthetic? Reversible loss of consciousness. That is known as general anesthetic. Okay. Then local anesthetic, loss of conduction of impulse from the localized area. That is known as local anesthetic. Okay. Why the word reversible is there? The consciousness will again retain. If it will not regain, then one patient will die. Consciousness will go forever. That means it will be die. Okay. That's why the reversible word is there. Reversible loss of consciousness. After 2 or 3 years, it will regain the consciousness. Okay. If it is a major surgery, 2 or 3 times will be required. If it is a minor surgery, half an hour or 1 hour will be required. After 1 hour or 2-3 hours, the consciousness will have to regain. Okay. That's why the word reversible is there. It is also used as anesthetic. That is chloroform. Chloroform is used as anesthetic. Okay, these are the different uses of alkyl halides. Then methods of preparation of alkyl halides. Methods of preparation. It has been studied in +2 level. Again, we remind halogenation of alkanes. Halogenation of alkanes. The alkane carbon-carbon single bond. If it will be halogenated, it involves the substitution of hydrogen atom of alkanes by as many halogen like chlorine, bromine, fluorine and iodine. Methane react with chlorine in the presence of UV light or at high temperature, that is 300 degrees Celsius, to yield the methyl chloride. Methane, chlorine in presence of UV light, it will be converted to methyl chloride plus HCl. Addition of halogen acids like hydrochloric acid, hydrobromic acid, hydroiodic acid to form the alkyl halides. Ethylene, carbon-carbon double bond plus hydrobromic acid, it will form the ethyl bromide. Okay. Then action of halogen acid on alcohol. Alcohol reacts with HBr, HI to produce the alkyl halide. This is your alcohol. Hydroxy group is there. Then it will react with HBr to form the ethyl bromide plus water molecule. Okay, then we discuss whatever we have discussed by books, it will discuss by slides. Okay, nucleophilic substitution reaction, SN1 and SN2 reaction. A nucleophile is a species with an unsaturated electron pair, that is lone pair of electron. Nucleophiles means positive towards attraction towards positive charge. Which will be attracted? The negative charge. What is negative charge? Lone pair of electrons. Lone pair of electrons. In the bracket, it has been written lone pair of electrons. A nucleophile, a species with an unshared electron pair, that is known as lone pair of electron, react with an alkyl halide. This is the substrate molecule. Alkyl halide is the substrate. By replacing the halogen substituent, this is the leaving group. The halogen will be replaced. Okay, the halogen will be replaced. That is the leaving group. Okay, this is known as nucleophilic substitution reaction. Here, this is the nucleophile. This is the negative charge species with lone pair of electrons, and this is the alkyl halide. It is considered as substrate. The product will be this is R, and this is the nucleophile plus halide ion, X minus ion or halide ion. This is the SN1 and SN2 reaction. SN1 and SN2 reaction. In nucleophilic substitution reaction, the carbon and halogen bond of the substrate undergoes heterolysis, and the lone pair electron of the nucleophile is used to form a new bond to carbon atom. The old bond will be break down and the new bond will be formed. The halogen atom will be replaced. Then the nucleophile in the form of OH minus, it will form the new bonds. Okay. Then a nucleophile, that is known as nucleus loving. Nucleophile means, what is the meaning of nucleophile? Nucleus loving or positive charge loving. The positive charge loving, which is the positive charge, the negative charge species, okay, is a reactant that provides a pair of electrons to form a new covalent bond. There are two types of nucleophilic substitution reaction, that is SN1 unimolecular nucleophilic substitution, then SN2 bimolecular nucleophilic substitution. Okay, then this is the nucleophile, OH minus, the lone pair of electrons are there. This is the alkyl halide, this is the substrate, then the newly formed compound is alcohol, and this is the leaving group. First of all, we have to discuss about SN1 or unimolecular nucleophilic substitution reaction. The SN1 reaction, SN stands for nucleophilic substitution and 1 represents the rate determining step is unimolecular. It will, the rate depend on the concentration of the substrate only. Okay, the rate of SN1 reaction follow the first order rate law, that is first order kinetics. According to kinetic of reaction, their rate depends only on the substrate concentration, that is S. The rate of reaction is directly proportional to the concentration of substrate, or the rate is equal to small k, this is the rate constant, and the concentration of alkyl halide only. The order of reactivity of the substrate for SN1 reaction is the reverse of SN2 reaction, that is third degree or tertiary is greater than secondary, then it is greater than primary. Okay, are you all understand? Yes. Example, hydrolysis of tertiary butyl or SN. You are understanding? Huh? It is थोड़े तो बुझी सर ना वही रे आउ थोड़े खाली प्रेजेंटेशन बुझे. Example, hydrolysis of tertiary butyl bromide to form the tertiary butyl alcohol. This is the tertiary butyl bromide. It will be converted into tertiary butyl alcohol. This is the example of SN1 reaction. SN1 reaction, because the third degree suites for SN1 reaction, then secondary, then primary. Primary is very rare. This is the tertiary butyl bromide. Okay, tertiary butyl bromide. This is the third degree butyl bromide. Then it will, the product form is tertiary butyl alcohol. Okay. Then SN1 reaction, the mechanism of SN1 reaction involves the breaking of carbon halogen bond to form the carbocation intermediate. Okay, in case of SN1 reaction, the breaking of carbon halogen bond to form the carbocation intermediate followed by the addition of nucleophile. First, the intermediate will be formed. It constitutes of 3 steps, step 1, step 2 and step 3. In the step 1, formation of tertiary butyl carbocation. Carbocation will be positive ion is known as cation and negative ion is known as anion. Okay, formation of tertiary butyl carbocation by separation of bromide anion from the carbon atom of tertiary butyl bromide. This is your tertiary butyl bromide. The carbocation will be formed and bromide ions, negative ion, will be eliminated out or liberated out. And in the step 2, why you are making sound? Clearly, it is clearly visible. Okay. Then nucleophilic. Then in the step 2, what happens? The nucleophilic attack. In the first step, carbocation will be formed. In the first step, the carbocation positive ion. This is the carbocation. In step 2, the nucleophilic attack of the carbocation by the water molecule, resulting in an oxonium ion intermediate. This is the oxonium ion. In step 2, the oxonium ion will be formed. How it will be formed? Nucleophilic attack of the carbocation by the water molecule. This is the H2O, H on O. Okay, it contains a lone pair of electron. Lone pair of electron is a nucleophile. It will attack the carbocation. this nucleophile, this lone pair of electron attack the central carbon, that is carbocation, and it will form the oxonium ion. This constitutes the step 2. This involves in step 2. This is the oxonium ion. This is oxonium ion. Then in step 3, the deprotonation of the protonated nucleophile. Okay, deprotonation means positive ion will be cancelled. The positive ion will be cancelled from the oxonium ion. In the oxonium ion, this is positively charged. The oxygen is positively charged. The positive charge will be cancelled by the nucleophile, another nucleophile. This is also a water molecule. This is the lone pair of electrons. This electron will cancel the positive charge of the oxonium ion, and it will form the tertiary butyl alcohol. This is the tertiary butyl alcohol. This is the final product of the SN1 reaction. Then hydronium ion will be liberated out. Hydronium ion plus tertiary butyl alcohol. This is about your step 1, step 2 and step 3 of SN1 reaction. Okay. Then in your intermediate level, this is a easy way to understand the SN1 mechanism. Involves two steps. In the 3-step mechanism we have studied, and for easy determination or easy understanding, it involves 2 steps. In the first step, the alkyl halide ionizes to give a planar carbonium ion. This is the planar carbonium ion. It is present in a plane. It is present in a plane. This is the planar carbonium ion. The tertiary butyl bromide will form the planar carbonium ion. Carbonium means positive ion. At the central carbon, the positive charge is there, plus bromide radical. Then in step 2, the nucleophile can attack the planar carbonium ion from either side to give the product. From both sides. This is the positive charge carbon, and this is the nucleophile. O is minus. This is the nucleophile. It will attack from both sides, from either side, from both sides of the carbocation to form the tertiary butyl alcohol. This is the tertiary butyl alcohol. This is the easy way of understanding of SN1 reaction. It involves 2 steps. Okay. Then solvent effect. Polar protic solvent like H2O and ROH favor the SN1 reaction. These are the protoic solvents. Okay, these are protoic solvents. It will provide protons. It will provide H plus ion. Okay, polar protoic solvents like H2O and ROH favor the SN1 reaction because the ionic intermediates, both cations and anions, are stabilized by solvation. Solvation means when the solvent molecule interacts with solute, some energy will be liberated, or it will be absorbed. That energy is known as solvation energy. Then stereochemistry SN1 mechanism forms a racemic mixture of 2 products. It is called racemization. In your internal and semester examination, short question arises like what is racemization? Okay, and you have to write in this way. SN1 mechanism form a racemic mixture. What is a racemic mixture? Okay, the isomers 50% and 30, 70, 60, 40. These are the racemic mixture of both 2 isomers. Okay, that is known as stereochemistry or racemization. From the 2 sides, the nucleophile will attack. If from this side, one type of structure will be formed, stereochemistry will form. If the attack is from back side, another type of compound will form, and it is a racemization. Means 30, 70, 30 and 60, 40 ratio formation hoba. That is known as racemic mixture. Okay. Then SN2 reaction, nucleophilic substitution bimolecular. The SN1 reaction, SN stands for nucleophilic substitution, and 2 represents the rate determining step is bimolecular. Here it is a bimolecular reaction. Okay. Rate of SN2 reaction follow the second order rate law, second order rate kinetics. Bimolecular means the rate of SN2 reaction is directly proportional to the concentration of 2 reacting molecules, the alkyl halide, that is substrate, and the nucleophile. The rate of reaction depends on the concentration of both substrate and nucleophile. That's why it is a bimolecular reaction. Thus it is known as SN2. Substitution nucleophilic bimolecular. Okay, the rate of reaction is directly proportional to the concentration of substrate and the concentration of nucleophile, or the rate is equal to small k into the concentration of alkyl halide and the concentration of nucleophile. Okay, k is the rate constant. K is rate constant. Are you understanding all? Yes. The order of reactivity of the substrate for SN2 reaction is primary, then secondary, then tertiary. First degree, second degree, and third degree. It is just opposite to the SN2 reaction. Okay. SN1 and SN2 reaction are just opposite to each other. Then example is hydrolysis of methyl bromide by aqueous sodium hydroxide to form the alcohol, to form the methyl alcohol. The methyl bromide hydrolysis, the hydrolysis of methyl bromide to methyl alcohol. It is the best example of what? SN2 reaction. SN2 reaction. SN2 reaction. Bimolecular. Okay. The rate is proportional to the concentration of both substrate and nucleophile. You are not listening. You are waiting for a video. Okay. Then mechanism of SN2 reaction. This is the mechanism of SN2 reaction. The mechanism of SN2 reaction involves the simultaneous formation of the carbon nucleophile bond. It is a simultaneous bond formation and bond breaking. In the intermediate stage, simultaneous bond formation and the dotted lines are there. The dotted lines indicates that simultaneously the new bonds are formed and the old bonds will break. Okay. The mechanism of SN2 reaction involves the simultaneous formation of the carbon nucleophile bond and the breaking of the carbon halogen bond. In the SN2 reaction, nucleophile carbon bond formation and carbon leaving group bond breakage happen simultaneously. In the transition state, the carbon is partially attached to both. This is the transition state, and the OH and bromine, the OH ion and bromide ion are partially bonded, are not fully attached, partially bonded. Then the leaving group will be liberated out and the new bond will be formed with the OH minus. This is the product form. Methyl alcohol, this is the methyl bromide, and this is the intermediate stage or transition state. Okay. Then stereochemistry. Time here. Okay. Then stereochemistry. Stereochemistry, it involves SN2 mechanism always proceed from rearward. Listen. The SN2 mechanism always proceed from rearward or backside. From the backside, it is always from the backside. Okay, rearward or backside attack of the nucleophile on the substrate. This process results in the inversion of the relative configuration going from starting material to the product. This inversion is known as Walden inversion. In the previous internal examination, this question has been arised. What is Walden inversion? That is rearward or backward side attack. Due to rearward or backside attack, the product form will be reversed. That is known as Walden inversion. Then solvent. The polar aprotoic solvent are used in case of SN2 reaction. Without OH favors SN2. Example of polar aprotoic solvents are acetone, dimethyl sulfoxide, NN dimethyl formamide, etc. These solvents are used or favors SN2 reaction. But in case of SN1, water is used as solvent. Okay. This is all.